Good, ma'am.
Okay.
This
So
call is now being recorded.
we have to do two topics in chapter 5, in unit 5. So we will be completing that. So the first one is to be completed is this enterprise analytics and search. In this chapter, we will study what is enterprise analytics and how a search is performed. As you know that analytics is all about measuring, analyzing various aspects of a system. So here, uh, enterprise operations contain hidden patterns that, if discovered, provides insights to the employees, administrators, and all the stakeholders so that they can improve the business strategy. They can also optimize their operational processes. And such knowledge discovery tasks are supported by analytical applications. When you have, for instance, let us take an example, students' details, student name, roll number, marks, and all. Suppose I have in my database, I would like to discover some patterns. Which student is obtaining what marks, and what are the students' uh, parameters or characteristics besides marks. Then I can relate. Okay, this student is scoring more, maybe because of this. Like that, I can analyze, and that way we can essentially discuss this with students, counsel them, and try to uh, make them improve their results. So discovering the knowledge, hidden knowledge, is useful to improve the business strategy and to optimize the process. This is all supported under analytical applications. And apparently, you know what a search is. During a day, we perform so many searches on Google. So then, this question, similar enterprise interest in enterprise search has been fueled by the increasing amount of text, mainly unstructured information generated and maintained by large enterprise, and the use of search technologies to index such data. There is a huge database of information of an enterprise available. What one can do, one can pose a query or search for a particular item, particular information. So this is nothing but enterprise search. Enterprise search is all about searching the enterprise data within an enterprise, in enterprise database. And analyzing this database is enterprise analytics. Enterprise knowledge, goals, and approaches. Coming to this topic, what are the goals and approaches of enterprise given an enterprise knowledge? What is enterprise knowledge? Enterprise knowledge is all about knowing the customers knowing the selling of products, buying of products, and various patterns involved in buying, selling. So, what they can do? They can segment customers, suppliers, markets, or employees based on their behavior. Segmentation is there are, suppose, consider 100 customers are there. Out of these 100 customers, 30 customers belong to age less than or equal to 25. Okay, so less than or equal to 25 means greater than 25. Mm, Wait, 25 age and 40 age and 60. So if suppose a few customers are less than or equal to 25, okay, this is equal to, and this one is less than or equal to 40 and greater than or equal, no, greater than 25. Okay, this one will be less than or equal to 60 and greater than 40. This is less than. Okay, so this is 30, 50 and 20. Certain product is purchased by 100 customers, and these customers have been segmented in the sense that they are formed into groups based on certain parameters. Here the parameter which we have taken is age. This is age, and this is total number of customers. Like that we can take any other parameter. The goal here is to segment the customers, means form the groups. This is one segment. Partition into distinct groups. If we partition into distinct groups, we get to know uh, which group is inclined for the purchase more, so that we can target that group through various other um, advertisements or some offers. So that way, that is custom segmenting. You can segment customers, you can segment suppliers, markets, employees, based on their behavior. And this analysis is used to decide which customers to give a discount and which supplier give more business. This is useful. This is giving us insights. Okay, like that we get to know about many different things. And then targeting advertising and marketing campaigns more effectively by determining what information need to be pushed. All right, so advertisements are targeted, campaigns are organized, all because they are analyzing, they are performing analytics, detecting anomalies or rare events such as credit card or insurance false claim, fraud, illegal duplication of mobile phone. These things, how is it possible? It is possible only through analytics. That's why big data analytics is a very widely used area nowadays, which is trying to give insights into huge amount of in unstructured data, and identifying problems and opinions from customer feedbacks, blogs, emails. This is also possible. Assessing overall situations and trends by fusing evidence from multiple sources. This is also possible through analytics. You might have heard about this online analytics processing. These are tools that allows user to view summaries. We do this, select a star from students where, um, or we can say select average of marks from student group by student age. Like we can generate summaries through Olap. Business intelligence, it's business intelligence application is to generate reports that aggregate operational details of enterprise summarizing business performance. For example, sales analysis may require viewing quarterly sales of products from different categories. Reports are generated. From the reports, again, knowledge is obtained, analysis is performed. That is all useful for improving and enhancing and getting making things better. All right, so this is all about aggregate operational details, and that will give some kind of detailed overview that makes uh, business operations intelligent. How can we bring about intelligence? We can have very conscious decisions taken from the data that is there in the system. Data warehouse, the collection of data is placed in a type of data which is known as a data warehouse, and this data warehouse is useful for extracting and transforming operational data into this reporting database known as data warehouse. In data warehouse we have data stored, and this data you can retrieve this and you can obtain the reports from this, generate summaries, aggregates. For example, this is one report: quarterly product revenue by category and region. This is category and region. Category is consumer and enterprise. These are the two categories. Regions, these are the four regions. In region US, quarter one means in a year we have 4 quarters. So first quarter, consumer purchased 100 products, enterprises purchased 90 products. Like that, we obtain a aggregate report uh, based on certain parameters. Here we are using category this way and region the other way. Olap on a star schema. Star schema is a type of schema like this one. This is known as a star schema, where we have you can consider that like tables. These tables are there and these are connected. This sales fact is connected to location dimension, and this is also connected to product dimension and to time dimension. So this forms like a star shape like this. It connects to like this. It connects. So this way it forms a star shape. And in this is a SQL query. Select sum of amount. This is summary. P category, L dot sales region, T quarter. From sales facts S, product P and location L, time T. You see here, these are the tables. Location, sales, time, product. From these tables, we are trying to obtain the sum of amount, category, sales region and quarter. Here there is a join being done between S dot PID and P dot PID, means sales facts and product. S dot aid and L dot aid. S is sales facts and L is location. S dot DID, T dot DID. This S is sales facts and T is time. So you performed a join, and also you are grouping by category, by sales region and by quarter. Here you see, by category grouping means what? This is one group, this is another group based on category. Based on quarters, there are four groups in each category. Based on region, we have four groups. That if you write that query, we get the information which has been obtained from multiple tables, and which is actually a summary and report kind of information that we are receiving. This is another query. You can just go through that. And Olap using Mapreduce. Mapreduce is a technology wherein you split the huge data into multiple parts, and then each part is then processed, and subsequently the information obtained from multiple parts are combined to give the overall processed information, that is map reduce. Olap can be performed on map reduce as well. Map reduce paradigm. You see, this is how um this summation operation is yielding a set of m aggregate measures to be placed at the appropriate cell in the final OLAP matrix. Here, matrix is created. Why matrix is created? Because essentially we are obtaining the information from multiple places. It is like uh, distributed computing and parallel computing, where one machine will send results, another will send another result. Like this, results are obtained from multiple sources and combined to generate a large result. So that is placed in a matrix from different various sources. Okay, and then parallel efficiency of OLAP using MapReduce is about um, how we can make the process of performing OLAP operations, this online analytical processing operations, are using MapReduce, and how the efficiency is improved. How efficiency is improved? Because we are performing the task on multiple machines. Okay, so here parallel efficiency of OLAP using MapReduce, we are computing. The number of reducers is a small constant unrelated to the data size. Reducer. In MapReduce, there are two components. You have processors and reducers. First, that each column of A contributes to exactly one of the columns of this sigma. Let us assume that the distribution of this contribution is uniform. So each of C aggregates in the final result on average a sum of n by C columns of A. N is what? We have C aggregates C. N perhaps is reducers, number of reducers. So n by C columns of A. A is a matrix. And these are the assumptions, and with this assumption each column of S has approximately n by C non-zeros and t1 the time taken to compute on one processor, because there are multiple processors, and therefore approximately m into n by C into C is equals to mn. Here the unit of time is that required for a single addition. This is the time required for a single addition. And similarly the time to compute each product sigma j is equals to this a and s, both when you multiply then we get the product, because matrices means matrix product we have to compute m into k by c, which is equal to m into k. Okay, the reduce phase involves each mapper. Okay, mapper and reducer. Sorry, I said processor, but it is a mapper and reducer. Mapper sending a vector of length mc to the single reducer, and the time compute sigma using p processor and one reducer is where d is the time for data transfer. So here the Olap operation will take t1 by ptp is equals to mn. Here we got mn for each operation over p into mk. This is for generating the product. Uh, they data map and reduce like this. Data is split up and then mapped onto several processors. Okay, this is not working. Here you are getting mk plus dpmc for each reducer for p processor. So p into mk plus p square dmc. D is the data transfer time, which is equal to 1 over 1 plus p square dc by n. This is the efficiency is high if p square is less than or equal to n by dc. This all computation is done in order to find the efficiency of performing Olap on Mapreduce. Text and data mining. Analytics also involves mining of text as well as data. Data mining is different and text mining is different. Data mining is a general term. The data can be anything. However, text mining is specific to textual data. So that involves classifying the data by manually assigning labels, clustering data into groups. Clustering data is like this, forming groups. Classifying means if suppose there is a text which is a positive review of a particular mobile, then you are classifying that text to be positive class, to be in positive class. If suppose the review is a negative review, then you classify the text into negative review, negative class. So that is classification, clustering, identifying anomalies, if there are any frauds or errors, any crime happened, all that anomalies, analyzing patterns. Suppose an example would be, if a student is attending class regularly, writing assignments, and attending exams, may score more. So the pattern is like, if suppose all the students who are having attendance greater than 55% is scoring 70% and above, okay, greater than or equal to 70%. You can see here, greater than or equal to 70%. This is one pattern. All the students who are having attendance 20% and less, they are scoring say 50% or 40%. So this can be obtained, this can be generated as a pattern from the data, and predictions can be made. What predictions can be made? Suppose in this semester you have seen the students results based on certain parameters. Next semester you can predict uh, for the next semester results what the student will score based on again the parameters, and that is about predictions. Data classification is if there are multiple classes, like class, there is a, okay, digit classification. If you have to perform digits classification, how many digits are there? There are 10 digits: 0, 1, 2, and so on up to 9. So these are 10 digits. If you are classifying these digits, then you get 10 classes. What are the classes? 0, 1, 2, 3, 4. These are the classes. If 0 occurs in the data, it will go to this class 0. If 1 occurs in the data, it goes into class 1. Like that, you have categories or classes and you are classifying the data. This is known as data classification. Okay, this example is classifying documents, 8 documents characterized by the occurrence or absence of 11 possible keywords represented by the data matrix. These are the keywords. If this keyword is present or not present, based on that, it is equal to 1 if the ith term occurs in document J and a sub ij equal to 0 otherwise. If this keyword occurs in the document, these documents, there is a 1 denoted at that place. If it is 0, it means that the keyword does not occur in the document, it is absent. This is presence of a keyword's absence of keyword. All right, so this is data matrix for documents for keywords. Like that you can classify. Okay, and these are the categories. Let us partition the data matrix as, and then a common measure of the distance between data points ai aj is cosine distance between two vectors, defined as uh, there is this distance measure means, suppose a b, what is the distance? It is just 1, means after a you got b, 1. If it is e, then what is the distance between a and e? This is 1, 2, 3, 4. 4. All right. So the distance between two data points can be measured by a, a unit known as a cosine distance. Distance between AI and AJ. Okay. This is 1 minus AI to T into AJ by AI TAJ. This is the formula. This is used to find the distance between the keywords or between any two data items. Okay. And then there is another mechanism which is known as singular value decomposition or SVD. This SVD brings out a unified understanding of the structure of data when viewed in matrix form. This represents the data in the matrix form, and this is useful for various data mining tasks. Here to understand SVD, it provides insights into the structure of large data sets modeled as matrices. Each column of A is a linear combination of the columns of U, which are called left singular vectors. Similarly, columns of V are called right singular vectors. Means this document is represented in the form of a matrix, and this has got columns U column, V column. U column are left singular vectors, V are called right singular vectors. If the columns of A are very similar to each other, it is highly likely that it would be possible to express them as linear combinations of a small set. If they both are similar, this column and this column, you can represent them as linear combination. In the above situation, there will be k large singular values, with the rest being relatively much smaller. And these k dominant singular values and the corresponding k columns of U as the dominant singular vectors of A. So all operations based on matrices are performed and SVD is obtained. Computing SVD using Mapreduce. Mapreduce SVD can also be computed using Mapreduce, and all techniques for computing SVD are iterative. The number of steps is not deterministic, and the computation converges after some steps, so the results are accurate to the extent of machine precision. Earlier we saw SVD being computed on a normal data. Here it is being computed on MapReduce. MapReduce, we know that it is for big data. There is a mapper and a reducer. And how that can be done? In this, let us consider U, V, B, M by K matrices with columns. U, U has the columns U1 up to UK, V has the columns V1 up to VK. And then multiplication of A into V and AT. AT means transpose. Like if you say A is super T, A to the T, this means it is transposing. You are transposing A transpose into U can be executed in parallel using MapReduce. And we split the matrix A into P sets of columns. And similarly, V is also split as it also has a large number of columns. And look, we have to perform operations A into V, A transpose into U. Instead of performing on a single machine, in MapReduce, what can be done? It can be split up. It can be split up into p set of columns, and then you can perform on multiple processes. Like this is shown here: ATU, A transpose, U, and A. To compute A into V, P mappers compute each of the product of AI, VI, and a reduce operation computes the sum. One will perform multiplication, another will perform sum. That way you are doing the things in parallel. If you do the things in parallel, obviously the efficiency will improve, and the time taken to perform the operations will be reduced. Clustering data. Clustering data is about forming the groups of data without having information about their classes. In classification, the information about classes is present. However, in clustering, there is no information about classes. When there is no information about classes, the clustering algorithm has to figure out on what basis uh, these should be grouped based on the various parameters available in the data. Let us say age. You can form clusters based on age, or if you are doing for students based on marks, you can do. If you are doing for customers based on the amount of purchase, you can do, or the frequency of purchase, you can do. Various parameters to form the clusters. Here, clustering, we attempt to have classes in an unsupervised manner. Clustering is unsupervised method of grouping the data into different clusters, whereas classification is a supervised technique where classes are provided for the data. And here what we are doing is matrix formulation and SVD can be examined. N columns of A are the data points, are the linear combinations of columns U, singular vectors, in terms of these axes, which we call U space. And then you are performing sum of V transpose, and you are trying to obtain singular vectors of U to the 1 to K, and first few coordinates of each data point in U space, which are the first few rows, reveal the clusters. When you perform like this, we get the clusters. First two coordinates of each data point in U space, the first two rows of sigma v transpose R. This way, based on the values that are obtained by performing various computations, we get various clusters like this. Here the distance between these two data points is very less, so they are in one cluster, these are in one cluster. Basically, you are computing the distance and finding the clusters. Anomaly detection. This is about detecting a fraud, any error, anything unusual. This is known as outlier. If suppose 10 people takes the loan from a bank, there is a high possibility that 8 of them will repay. However, there is a outlier always there who is different from the others. So that outlier, say two people, these two are outliers, they are not repaying, or they are doing some kind of fraud. So that is detecting that is about anomaly detection. So outliers can often be identified by the columns of V transpose in which first k values corresponding to the dominant singular vectors are all small, and the corresponding columns of A are likely to be outliers, representing some kind of anomalous behavior. For example, using the matrix, we find that the columns with k equal to dr, these columns have been found that perhaps represent the anomaly. Okay, that is all about analytics. Moving ahead, it is about enterprise search. Search is quite ubiquitous with the advent of internet and a Google search engine. People search every day uh, for different things which they are looking for. Here, apparently, we will look at the search relevant to enterprise. Ranking search results is difficult for enterprise data. On the web, most popular results are assumed to be better. However, in an enterprise, one is usually more interested in the correct results rather than merely the popular ones. In enterprise, the focus is on correct things. On internet, when you try to search something, it shows up a list of links or pages, web pages, which are pretty popular. Okay, it is the metric is popularity. If a web page is popular for a particular query, it is shown up. Whether it is right or wrong, that is up to the user who is searching for the item to figure out. Google will not figure out that. And essentially, in enterprise, correct results are more important. Correctness is significant, and this is about enterprise search. The structure of web provides explicit information on how pieces of information are linked to each other, that is hyperlinks. These are far less explicit for enterprise data. Documents may contain names of same important customers, but these are unlikely to be explicitly linked, and any such relationship would have to be derived. The search which is made on the enterprise data would not have may not might not have all the customers, important customers, linked up. So that kind of that here we are studying the difference between general search and enterprise search. Information on the web is public, whereas enterprise data have security restrictions. A vast majority of information on the web is textual and uniformly located via URIs, uniform resource identifiers. Enterprise data, on the other hand, is a mixed bag of textual information linked to the structured records. This is the difference. Enterprise information is mixed bag of textual information linked to the structured record. There is textual information, there is a this structured records, perhaps in the tabular form. And enterprise data exists in a greater variety of documents and database. Indexing and search using Mapreduce. Indexing is about having an index. An index is a collection of keywords along with the uh, data or information related to their availability. In case of textbooks, you can find indexes would have keywords and the page numbers where you can find them. Likewise, indexing can be performed on the enterprise data so that search is made quick and easy using MapReduce. Using MapReduce in the sense that we are trying to again split the data and then perform the operation. So this inverted index, this is known as inverted index. These are the keywords, and these are the um, links where they can be found. Okay, and they are chained together. Okay, latent semantic indexing is a technique, LSI, that is used for advanced kind of search. The search which we discussed is a simple keyword search, and the result set contain only those documents that contain some or all of the query terms, ranked how closely they match. And simple keyword ignore two aspects of natural language that may be important in certain kinds of search, which is synonymy and polysemy. Synonymy, we have two terms such as code and program would have same meaning, so they are synonymous. And this synonymy need to be discovered and exploited in order to perform a better search. So if you search for code, it should yield those documents that contain program as well. Because of cosine distance ignores such synonyms and underestimates similarity. Polysemy is when the same term, such as a string, is used in multiple contexts. Poly means many. Polysemy in multiple contexts. You use string theory in physics, text string in computing, and nucleotide strings in biology. So strings, you see strings, based on the context, it is getting different meaning. And simple search overestimates similarity. Simple search do not consider all these factors. It turns out that SVD can automatically take into account both synonymy and polysemy to a certain extent. The technique that achieves this is known as latent semantic indexing. Latent semantic indexing is about considering the search to have the features of synonymy and polysemy. And here, to obtain the approximation of a suppose there is a document matrix A that truncate to the first k singular vectors and values, and to obtain the approximation AK, these operations are performed. These are some columns, and then you perform this. You represent all of these in the form of matrices. You take their sum, you take their product, and finally you arrive to this. Okay, that is computing cosine distance. Searching structured data. There is a huge difference between searching unstructured data and structured data. Structured data is a tabular format data. So how can we search? Applications that issue SQL queries are limited to the extent to which they enable search keyword. And different screens need to be accessed to find all occurrences of a keyword. And enterprise often have large number of applications that maintain their own interrelated but independent databases. So searching all of these simultaneously can be looked upon as a cheap and user-friendly way to provide integrated access. And related to the above case, often information about the same objects is present in a number of systems that are not well integrated. Search-based technologies could discover data relationship by automatically traversing common foreign key values. This is all about how search can be made on a structured database like this. This is one table, this is another table, and how can you perform a search technique on these tables? And SQL has join operation uh, get the data from multiple tables, and it is quite important to examine linkages between data items that are not explicitly maintained as joins. And in structured data is augmented with unstructured data, and it may be desirable to search both kind of data at once. So it's pretty different. Structured data and unstructured data is pretty different, and With this, we have done with our enterprise analytics and search topic. Next class, we will study enterprise cloud computing ecosystem.